Hey guys, I'm going to break down these acid-base imbalances real quick for you. Before I get started, I do want to point out these two notes that I have up here. Your mnemonic Rome, respiratory, opposite, which is talking about the pH and the CO2 will be opposite, and then metabolic, equal. So the pH and the bicarb arrows will be equal. And then also a side note, hydrogen bonds is acidic, and your bicarb HCO3 is a base. Okay, so with respiratory acidosis, your pH is low and your PCO2 is high. You're retaining CO2. It's with hypoventilation, so shallow respirations, something like a drug overdose. Okay, and then the way that the body is going to or should try to compensate for it is going to be fixing it. Okay, so if you're acidic, you want to increase your bicarb, right? Because that's base, and since hydrogen is acidic, you're going to want to decrease that. You don't want to get more acidic. And that's done by the kidneys, okay? With respiratory alkalosis, your pH is high and your PCO2 is low. You have a loss of CO2. This is with hyperventilation, anxiety attacks, paresthesia, pregnancy, increased altitudes. When you start breathing like that, you have a loss of CO2. That's why they have you breathe in the bag if you're hyperventilating, to try and get that CO2 back, okay? And your body's going to compensate for it the opposite way. So your kidneys will decrease your bicarb because it's a base and you're already there. And then it's going to increase the hydrogen because it wants to try and get more acidic. All right? So moving over to metabolic acidosis, you have low pH and low bicarb, HCO3. This happens with Kussmaul respirations, diabetic ketoacidosis, diarrhea, and renal failure. And the reason that it happens with renal failure is you're not excreting potassium. And so with metabolic acidosis, you're going to have a compensatory mechanism of the kidneys, the same as your one over here with respiratory acidosis, but here your lungs are going to compensate too. So you're going to have an increased respiratory rate to blow off or try and decrease that CO2 because there's too much, right? All right. With metabolic alkalosis, high pH, high bicarb, HCO3. So tremors, tetany. This will be seen with vomiting and excess antacids. Compensatory mechanism, again, the kidneys will be the same as over here, your respiratory alkalosis. And then your lungs are going to decrease your respiratory rate to try and retain or increase that CO2. And that is acid base in a box.